The hidden history of time, chronology, and how our calendar was really created. Chronology is the science of measuring time. It may sound dry at first, but behind the dates we casually write today lies thousands of years of observing the sky, experimenting with calendars, dealing with religious traditions, political power plays, and occasional human mistakes. Chronology helps us understand how different cultures measured time and how we can translate their systems into the one we use today. The field has two sides. Mathematical or astronomical, chronology studies the movements of celestial bodies and defines objective units of time based on them. Historical chronology examines how individual nations and cultures measured time in practice, how their systems developed, and how we can convert dates found in historical sources. This is what historians often need the most. Chronology, therefore, has both a practical purpose, converting old dates, and a theoretical one, which is to study how time measurement has evolved. The basic units of time are more complicated than they seem. A day is the time it takes Earth to rotate once around its axis, but even that varies slightly throughout the year. The longest day is about 51 seconds longer than the shortest. A month in ancient systems was based on the moon, especially the synodic month, the time between two new moons, which lasts a little over 29.5 days. A year, the time it takes Earth to orbit the Sun, also isn't perfectly neat. A tropical year lasts 365 days, 5 hours, 48 minutes, and 45.5 seconds. That small discrepancy is the reason behind all later calendar reforms. Because of these irregularities, different cultures created different types of calendars. The lunar calendar measured months strictly by the phases of the moon and ended up with a year shorter than the solar year. The solar calendar, like the one we use today, is based on the sun and the tropical year. Then there were lunisolar calendars, systems that followed the moon but occasionally added an extra month to keep the year aligned with the seasons. This brings us to ancient Rome, where the foundations of today's calendar were laid. The earliest Roman calendar had only 10 months and began in March. Winter was simply ignored. Later Roman writers usually credited this calendar to Romulus. Romans divided each month according to 3 key points: the calends, the first day of the month when the new moon appeared; the nones, around the first quarter; and the ides, the day of the full moon. Dates were counted backward toward these fixed points, a complex but functional system. The first major reform, traditionally attributed to King Numa Pompilius, added the months of January and February, and sometimes inserted an extra short month called Mercedonius to keep the calendar roughly aligned with the seasons. This created a lunisolar calendar, but it was still far from precise. The Julian calendar. By the 1st century BCE, the Roman calendar had become chaotic. The priests responsible for adding the extra intercalary month frequently abused the system to extend the terms of their allies or shorten the terms of their enemies. Time itself had become a tool of politics. Julius Caesar, determined to unify, stabilize, and modernize the Roman state, understood that an empire of such size could not function without a reliable timekeeping system, so he introduced a reform in 46 BCE. Caesar turned to one of the greatest astronomers of the age, Sosigenes of Alexandria, who brought with him the precision of Egyptian astronomy. Sosigenes proposed a solar calendar consisting of 365.25 days. This meant fixed lengths of months, a simple and consistent rule that every 4th year would be a leap year, and the complete removal of random additional months. To realign the old Roman system with the actual solar year, Caesar had to take a dramatic step. The year 46 BCE was extended to an extraordinary 445 days. This is why historians call it the last year of confusion. Only after this massive correction could the new Julian calendar begin. For its time, the Julian calendar was remarkably accurate, drifting from the true tropical year by only about 11 minutes annually. Although this seemed insignificant, the error accumulated over centuries. The calendar also fixed the lengths of the months we still use today, and some months bear the names of Roman rulers, such as July after Julius Caesar and later August after Emperor Augustus. In this way, Caesar literally carved his name into the structure of time. The Gregorian calendar. After more than 15 centuries, the small yearly error of the Julian calendar began to cause serious issues. The accumulated drift of 11 minutes per year shifted the date of the spring equinox by several days. This was a major concern for the Christian Church because the calculation of Easter, the most important Christian holiday, depended on the equinox. The Council of Nicaea in 325 CE had set the rule that Easter should fall on the Sunday after the first full moon following the spring equinox, but because of the growing drift, the equinox no longer occurred on March 21 as intended. In the 16th century, Pope Gregory XIII decided to resolve the problem and gathered leading astronomers and mathematicians. Among them was Christopher Clavius, a Jesuit scholar who played a crucial role in designing the new system. The resulting reform was both elegant and effective. First, the accumulated error was corrected by removing 10 days from the calendar. In 1582, October 4th was immediately followed by October 15th. Then, the leap year rule was adjusted to prevent drift in the future. A year would remain a leap year if divisible by 4, but years divisible by 100 would no longer be leap years unless they were also divisible by 400. This simple change created a calendar so precise that it will drift by only one day in about 3,300 years. The calculation of Easter was also updated to reflect astronomical reality more accurately. But the reform was not just a scientific endeavor. It had a dramatic social impact. When 10 days were suddenly removed from the calendar, many ordinary people felt as though something precious had been taken from them. In several regions, confusion turned into anger, and crowds gathered demanding, "Give us back our days!" Some workers believed they were being cheated out of wages, while others feared their lives had literally been shortened. Although later historians exaggerated the scale of these demonstrations, they reflected a very real anxiety. The idea that authorities could delete time was profoundly unsettling. As with many major reforms, the change was not adopted everywhere at once. Catholic countries accepted the Gregorian calendar immediately, while Protestant and Orthodox regions resisted for decades or even centuries. Europe operated under two different calendars for a long time. England did not switch until 1752, and Russia waited until 1918, after the Bolshevik Revolution. Today, the Gregorian calendar is the global civil standard and serves as the shared framework by which the world measures days, months, and years. Even though many cultures continue to maintain their own traditional or religious calendars alongside it. The birth of modern chronology. Even after the Gregorian calendar was introduced, people in Europe did not immediately start using dates the way we do today. For a long time, everyday timekeeping still depended on religious traditions and the rhythm of the church year. Instead of writing June 24th, someone might say, "on the feast of St. John," or instead of December 6th, they would write on St. Nicholas's Day. Many documents did not include numbers at all, only references to saints, holy days, or seasons like Advent and Lent. Time was experienced as a cycle of familiar celebrations rather than a sequence of numbered days. Historians today often have to decode these references. To understand when something actually happened, they must know the dates of feast days, which ones were fixed, and which ones moved each year depending on Easter. A simple sentence such as 3 days before the feast of St. Michael can require a surprising amount of calculation to place correctly in the modern calendar. Numerical dating, the way we write dates today, only began to spread widely in Europe during the 17th century. Until then, people still relied heavily on traditional, church-based expressions of time. Instead of writing dates with numbers, documents were dated by feast days, agricultural seasons, or references such as on St. John's Day. The transition towards standardized numerical dates was slow, uneven, and different from region to region. Complicating this shift was the fact that Europe did not use a single dating system. Various regions followed their own styles of counting the year. In Bologna, for example, the year began on March 25th, the Feast of the Annunciation, a method known as the Bolognese style. Florence used a similar but slightly offset system, while Venice counted the year differently again. Many medieval documents also relied on regnal years, dating events by how many years a ruler had been on the throne, or on indiction cycles, a repeating 15-year administrative cycle inherited from the Roman Empire. To interpret such dates correctly, historians today must know not only which calendar was in use, but also which local dating style the document followed. This is why the rise of modern chronology in the late 16th and early 17th centuries was so important. Scholars such as Joseph Scaliger and Dionysius Petavius created comprehensive chronological tables, conversion systems, and methods that connected these countless dating styles into one coherent framework. Thanks to their work, an entry like the third day after the Feast of St. Michael, or in the 8th indiction, can now be converted into a precise modern date. Chronology became the bridge between the past and the present, a discipline that finally made it possible to place all of human history on a single, continuous timeline.